Hello, good afternoon. My name is Kulbhushan Grover. I'm an associate professor at New Mexico State University in the Department of Plant and Environmental Sciences. Today, I'm going to talk about a very interesting new plant or relatively new crop that we are testing here in New Mexico. It's called guar. It has a lot of potential because of its unique features as a crop in our area, which is more dry and hot. So, I will be talking in detail about this plant in my next slides in this presentation. Guar actually is a Hindi word, comes from Indian national language, Hindi, which means cow food. So it has been grown as a forage, just like alfalfa, as cow food for centuries. Actually, the English name is called cluster bean because it grows beans in clusters on the plant. So we call it a cluster bean. So it's a bean plant, has a lot of beans on it. It's a legume crop, just like alfalfa, soybean, or pinto beans. And it is one of the most drought tolerant crops that we know. So it can be really used for, in dry conditions, in arid conditions like we are here in New Mexico. So, like I said, this can be grown for forage, for green biomass, protein. It's a legume, it's a bean plant, so it's a really rich in protein. It's a very good uh, type of feedstock for livestock, and it can also be grown for fresh beans, for vegetable, for cooking for humans. So many places like in India, where people are mainly vegetarian, so they depend on plants like guar bean for their protein in their diet. Now you can also grow this guar crop for the dry seed. So when the beans are dry, like you see in this picture, they are showing green beans. But if you let these beans dry, they have very dry seeds in it. And actually, I have a plant here which is kind of close to drying. I don't. Hopefully, you can see at least a little bit of it. Um, and when you harvest the seeds, they look like this, very small little rock like seeds, like you see in this container. Um, so why we want to harvest the seed? They are used to produce what we call as guar gum. And do I mean from guar gum? So you have the green beans. You When the green beans are dry, you take the seeds out of it, like I showed you these seeds. So if you look at the seed, it has one outermost covering. We call it hull, like in this picture. And then inside there are two parts. One is what we call as germ, which is the reproductive part, or which when the seeds germinate, that gives rise to the new seedling. And then the remaining part is what we call as the endosperm, that is more sugars and carbohydrates, kind of as a food reserve for the new seedling. So the guar gum basically is when you separate this endosperm part from the rest of the parts of the seed and grind it, so it becomes like a powder, like you see in the picture on the right side. So if you mix it in water, it becomes like a sticky gum-like substance. So that's why we call it as gum. And because it is produced, it is derived from this plant called guar, so we call it as a guar gum. So I have a little sample that I'm going to try to show you how it looks. So if you can buy this guar gum, is used in so many different products. I'm going to talk about a little bit, but this is like one of the containers that it's a food grade guar gum, um, and I'm going to try to show if it is visible. It's just like white powder, like a wheat flour. um, and I'm going to try to give you a little demonstration here. So I'm just using half teaspoon and put it in this little container, and then I'm gonna add some water into it, and hopefully it is still clear. and I'm going to uh, try to mix it. So now you can see it became really thick, gel like substance. So that's what we call as guar gum. Now, why we should care about this, or why this is important? This guar gum has very unique chemical properties or biochemical properties. um, if you look at the guar gum, like I mentioned earlier, it's mainly the endosperm part, so it's about one third of the whole seed. uh, Chemically, um, the guar gum has several components. I'm going to talk about it. Once you separate the endosperm part, the gum part, you can also have several other derivatives that could be used, like the seed coat or the germ. They could also be used for different purposes. So the guar gum, like I said, chemically it's a polysaccharide. It composed of mainly two sugars, galactose and mannose. um, and those are high molecular weight sugars. Because of this, uh, this guar gum has very unique biochemical properties and rheological properties, or high viscosity. Like you see, it's very thick. It can change its viscosity depending upon the conditions, and that's what the different industries utilize in addition to its chemistry. Okay. It is more water soluble than many other gums that are used in different food products. For example, it's much better emulsifier. It's, for example, it's 8 times higher, has water thickening potency compared to cornstarch, which is also a very common ingredient in many food products, as we all know. Because of this unique property of guar gum, it is widely used as an emulsifying or stabilizing ingredient in range of food products and cosmetics. So I wanted to show here. I just have a sample of ice cream. If you can see, Bluebell ice cream, Bluebell, and one of the ingredients you will notice is guar gum in this. There's a. I also have a little bit bigger. Maybe it's not. So there are all different types of products that you will see guar gum as part of um, uh, the ice cream, or all many other food products. Like you see many other products: ice cream, cottage cheese, yogurt, hand lotions, cosmetics, lipsticks. So it's used in suite of different products, like this picture shows. It helps because of, again, its unique properties. It helps with the, for example, it doesn't let the ice cream grow the ice crystals, and provides good stability during freezing and thawing cycles. And it's also used in gluten-free ice creams. Okay. It's also a hydrocolloid, which is particularly useful for making thick paste without forming a gel. So it helps keep those products keep their texture, their structure, their shape. Like I said, it's used in so many different products: cottage cheese, yogurt, soaps. Um, it's also an important ingredient in textile industry for sizing, finishing, and printing. Used in paper industry, improved sheet formation, folding, and denser surface for printing. It's also used as a waterproofing agent um, in explosive industry. So there are a lot of different products that different industry make use of this guar gum. Like I showed you this container. Um, uh, Here, actually, it's used as a laxative in pharmaceutical industry. So there are several uses of guar gum. Well, most of these actually use very small amount of guar gum because of its really strong properties. Now, more recently and more interestingly, now guar gum is also being used as a gelling agent um, that helps stabilizing water and sand mixture in what we call as oil extraction technique. Sometimes it's called fracking, or hydraulic fracturing, or horizontal oil drilling. Basically, They drill the oil well, like they can go up to 10,000 feet deep into the shale. So it's relatively new technology that U.S. oil industry is using to explore gas from unconventional sources. And I have a little graphic that shows you this whole process. um, like I said, it is used. There are different terms that are used: hydraulic fracturing, fracking, horizontal fracking. It has been long been used to extract oil from depleted wells, but now it's widely used across the country to tap previously unreachable oil and natural gas that is locked within deep rock formations. So basically, they bore a well using directional drilling, a method that allows drilling in vertical and then horizontal direction. They can go up to 10,000 feet deep, like I said. And what they do is they create fissures through explosions, so that they can like sense the oil, and then they will suck the gas out of that back to the soil surface. Um, what they do is they because those fissures, those cracks would otherwise naturally collapse, so they want to keep those cracks, those fissures stay open. So what they do for that purpose is they create this slurry. Large amounts of water, sand, and different chemicals, they are injected into this well at very high pressure. That causes these fissures, and then the sand flows into those fissures, keeping them open, so that oil or natural gas from the shale can flow up out of the well. So where does the guar gum come in this whole picture? So like you can see in this mixture, they have been using several chemicals earlier, and because they are working through the water systems up to the like 10,000 feet deep, so there's always chances of leakage of those chemicals, which are toxic and can pollute our water sources. So there have been efforts to at least replace some of those chemicals with this plant-based natural product, guar gum, because it's a natural, so it's not that harmful. Um, because this hydraulic fracturing or fracking in itself is a relatively controversial process or technique. It can also cause seismic effects, and then this is another issue of possible mixing of chemicals into the water. So at least by using guar gum, some part of that issue is being addressed, by substituting it with this natural plant-based product. So once they have figured this out, they can use this natural product in this mixture. So there has been a lot of interest and demand in guar gum by the oil industry, because they are projecting big time oil production through this new technology or the shale gas. So this figure actually show you um, projections and history for coming decades, how or where the U.S. Oil and gas industry is heading. So they are uh, counting on this new form of gas, oil and gas, shale gas. So because that's the technology that I just showed you, that is what is used to get this shale gas, and that's where guar gum and hence the crop, the plant guar, comes into the picture. Now we know that we would need a lot of guar gum for this newfoundly use of guar gum in this oil drilling. It's not just you are using very small amount, right? So because of this big industry needing a lot of guar, there has been a lot of interest and demand for guar gum products by the industry. But domestically, we don't produce much of this crop here in the US. So we have relatively very small area. So pretty much most of the demand by the oil industry is met through imports from places like India, which is the largest producer of this crop. So I grew up in India. I worked on this crop, so I know this crop very well. So for example, in 2011, there was import of more than $1 billion worth of guar gum and related products. So this figure also show you the trend amount, how much money has been imported, spent on importing guar gum products. Looking at the future potential for this crop or guar gum, there are several big companies that are involved in this business of oil drilling. FTS International is one of them. They, for example, needs at least 1,700 tons of guar gum in just 1 month, which is 3 to 4 times of the annual US production that we produce everything in 1 year. They would need like 3 or 4 times in just 1 month. So 4 years of production they need in 1 month. So you can imagine how much demand is there. Halliburton is another big company that also is involved in this. So if you do little math, how much guar gum is needed for drilling each well, single well, like up to 20,000 pounds of the guar gum. uh, Basically it becomes like 90,000 tons of guar gum, because there were like 19,000 wells on an average, like in year 2012. So if we do the math, how much guar seed we can produce in 1 acre, and how much guar gum would come out of that 1 acre production of seed, because remember there's only about 28 to 30% of the seed is the guar gum. So it becomes at least 500,000 acres of guar crop or plant that we need to just meet the demand only for the oil industry, US petroleum industry. So remember, we also talked about many other industries that need guar gum. So it has become really an important product for these industries. So like I said, originally guar has been mainly a crop that has been grown in places like India, mainly in India and Pakistan, and it is grown on one of the driest places, Thar Desert. There, it really likes hot and dry weather, and New Mexico has an ideal kind of condition that where we can grow guar. So right now, in the U.S., the commercial production is mainly in West Texas and in some in Oklahoma. So the southwest part of the U.S., desert southwest, we sometimes also call, including West Texas, Oklahoma, Arizona, and New Mexico. We this region has ideal condition that we can grow this crop successfully um, here domestically to meet the demand for our industries. um, and also on the other hand, because of the kind of the climate of issues we have been hearing or having in our region, less and less water, less and less rainfall, more droughts. So farmers are also struggling to grow crops, to grow plants with minimum water, that they are the reducing amounts of water that we have. So we need some crops that we can still successfully grow with less water. So that's where guar comes into the picture. So it really is an ideal crop for our area. It can grow with the under low water and hot conditions, and it can also have good economic value, because of the oil industry and other industry that they need it in their products. So with that background and my own experience back in India, so when I joined New Mexico State University a few years back, I started looking at as an alternative crop that we can grow, that needs much less water, more drought tolerant than many other crops that we grow locally here. Because in southern New Mexico we have what we call as irrigation water. We have wells, so we can grow this crop with supplemental irrigation. You can also grow this crop as a dry land, but the production is low. But if you have water, you can add more water through supplemental irrigation to the rainfall that whatever we receive, so we can have more higher productivity. Another good aspect of this crop is it's a legume crop, which means uh, it belongs to legume family, or it's a bean, just like soybean, pinto bean, alfalfa, those kind of crops. So there is a unique feature about these crops that on their roots they have a round ball like structure. We call them nodules. So in those nodules there are certain type of bacteria that reside. We call them as rhizobium bacteria. So those rhizobium bacteria and the roots of these legume plants, they have what we call as a symbiotic association, friendly relationship. So they help each other out. So the roots, they provide food or carbon to the bacteria. Bacteria in return help these plants to what we call as fix nitrogen, which means there's a lot of nitrogen. 78% of the air that we breathe is actually nitrogen. But plants, for their full growth, they also need food, or what we call as nutrients. So nitrogen is one of the major nutrients that most of the crops need. And farmers, they spend billions of dollars every year buying nitrogen fertilizer from the market, like urea. Okay. um, but on one hand, we have this nitrogen in abundance in the air, like 78% nitrogen. Oxygen that we all need for breathing is only 20% or so in the air. And carbon dioxide is less than half percent, which is one of the major greenhouse gases that we talk about the climate change, global warming, that has been increasing in concentration. But if you compare carbon dioxide versus nitrogen, it's much higher concentration in the air. So the plants need that, but plants cannot use it. But on the other hand, plants can use carbon dioxide for the photosynthesis process. The reason is the nitrogen that is present in the air is in gas form, and plants cannot use it as such. It has to be converted into what we call as nitrate or ammonium form. So not all plants can convert it in from nitrogen gas to nitrate form. These plants, legume plants, are only capable of doing that. That's what we call as nitrogen fixation, biological nitrogen fixation, with the help of those bacteria I talked about, rhizobium bacteria. So those bacteria help converting these legume plants nitrogen gas into nitrate form. So which means if you are growing these plants, you don't have to buy fertilizer from the market as a grower. So it saves you a lot of money on those fertilizer. And of course it will also help the environment, because you are not now using synthetic chemicals, fertilizers that were produced in the factory. Now you are using natural source of nitrogen. So it helps on saving energy manufacturing those fertilizers. And also, when you use those fertilizers, they end up in the soil, in the water, in the air, polluting the environment. So you also help in that regard. So legume crops are generally good rotation crops. So that's what it means. uh, Guar can be a good rotation crop. It helps building the natural soil fertility, the nutrients in a natural way in the soil. So you don't have to spend money or spread the chemical fertilizers in the soil. Another good aspect about guar is that it's a good rotation, which means if you follow any other normal conventional crops like corn, cotton, sorghum, other non-legumes, after in the previous season growing guar, it helps increasing the yield of your crop. For example, in one situation you have year one, you have in 21 you had cotton grown on your farm. In 22 you have cotton again. And if you compare it with, if in 21 year one you had guar on the field, but in next year you have cotton, so you are following cotton after guar. So there has been seen increase in lint yield, for example cotton yield up to 15%. Again, that is economic benefit, so that helps improving the income of the farmer. Okay. So it's also a relatively low risk, low cost of production crop. So when there's extreme drought, and actually it is a winner compared to crops like cotton if it is extreme drought conditions. So it is a suitable crop for our area. So with that background, we did a lot of research on this crop. So collected different seeds from different parts of the world, what we call as the genetic germplasm. And we did some prelim research at New Mexico State University, here at Las Cruces campus, the main campus in southern New Mexico, looking at it. Can we grow it? Can we grow it for forage, or would it still produce seeds? So out of those, we had several um, students involved in this research also. uh, Several high school students came for internships, helping with these projects. So we looked at some of the guar plants. They would grow really well. Others would grow well uh, with beans, nice beans, but there would still be others that you would probably produce flowers but no beans. So all of this research has helped us, and also looking at several parameters. When we grow these, we compare different genotypes. We look at their performance. which one would give us the best yield. I'm not going to go over the number, just to show, then we also look at the quality of the guar gum, because that's the industrial product. What is the value for those? So we have been doing a lot of research on different aspects for this plant, because when you are bringing in a relatively new crop for the area, so you we need to tell the farmers what is the best time to plant this crop. So we looked at what would be the best time. We figured that it will be probably mid-June, when we can grow this crop successfully in our area. This is just picture of showing some of those research plots. We there are a lot of research parameters like photosynthetic activity, photosynthesis, those kind of things that we look at. Of course, we also look at the productivity of these plants um, under different planting dates. And we, like I mentioned earlier, we found that mid-June planting is the best time. We also look at how much time it takes to mature, to harvest these crops. And again, depending upon which variety we are using, there are different varieties. Some take lesser time, close to 100 days. Others would take more than 100 days. And we did this research in southern New Mexico. We also did it in the eastern part of New Mexico, so that we can have more wide recommendation and see whether it's kind of similar results. That's exactly we did find, um, that we can grow this crop guars successfully in New Mexico, in eastern as well as southern New Mexico. And since then we have been doing this research in many places, pretty much all parts of the state. And as far as the time of the planting, we found that first fortnight of June is the best time to plant. And depending upon which genotype or which variety you choose, there will be slight differences in their performance. So this because the background that the information that I provided in the beginning, the importance of this crop. So we have a lot of people from other places, other countries, visiting us and looking at this research and exploring possibility for their countries also. Because again, oil is a big energy, is big aspect. And US oil industry is kind of leader in the world right now in this new, relatively new technology that we talked about, where the guar gum is utilized. So there's a lot of interest. So we started this project, relatively small scale, but recently, few years back, with several institutes. University of Arizona was the main institute. We had this, project that was funded by U.S. Department of Agriculture. It's called Sustainable Bioeconomy for Arid Region, where we are looking at guar as a potential crop, in addition to one more crop. It's called violi, which is grown for mainly for latex, or the rubber, natural rubber. So it's now guar research has become a big teamwork across many disciplines. Like I said, we are looking at the research, we are looking at the education. As we speak, there are several schools, middle schools, that are participating in this program. We have teams of graduate students and faculty from our university who are collaborating with high school, middle school teachers to educate kids, different students, on the importance of these new plants for helping sustaining bioeconomy for our arid regions. And we have a lot of industry people like Bridgestone, Guar Resources that are involved in this collaboration. So there are a lot of different aspects that we are looking at on this crop to make it successful in our area. I mentioned earlier about the nodules, or that are the round structure that where the bacteria reside on the roots. So the lower picture shows exactly how those nodules look like. There are several different. We're looking at what is the best population planting density, for example, to have this crop grown successfully. So there are different aspects to make it again successful crop. And we also spread awareness. We talk about this crop. This was one of the project that was invited for presentation at the U.S. Congressional Research Exhibit in 2019. There are a lot of other extension outreach activities that we do to make aware, create awareness about this plant and its importance. And it's also at the university, we had, for example, college open house where a lot of people from community talking about this plant. So there's a lot of interest in this plant. So this program has, this project has received support from a lot of different agencies. So that has made it possible, their support. So with that, I would like to thank, and if anybody has any questions based on this presentation, my contact information was provided at the very beginning, in the first slide, and I have brought it back. So um, it has my email and also my phone number. So please feel free to contact me with any question that you may have. Thank you.